types of data. There's basically two broad types of data. Easy to figure out the difference. Easy. Did you get it? How tall are you? 5'3". 62 inches. Penny is 62 inches tall. Great. That's a characteristic that describes her. She's 62 inches tall. What color hair do you have? Brown. Great. Two different types of data, isn't it? We call this quantitative. We call this qualitative. The reason we call the one quantitative versus qualitative is because qualitative gives me things that are kind of categories. Okay? A brown hair, a blonde hair, black hair. Quantitative data, and this sounds really mathematical, is data that can be measured on a naturally occurring numerical scale. I know that sounds like a little mouthful, right? But it just means that I can put a number next to it. That makes sense to everybody? Let me give you some examples, other examples of not qualitative, but quantitative data. Weight. Temperature. What? How many people in the house? How much money you earn? What's your salary? Okay, you know, I go get a Coke from the dispensing machine. You know, it fills up Coke. Okay, am I really getting 12 ounces or do I get 11.9 ounces? Okay, I can measure that. How fast people run, the miles per gallon on car. Right? It's all data that can be measured on a naturally occurring numerical scale. How about this one? How many people have a, I don't know, flat screen TV in their home somewhere? Okay, most people have a TV in their home somewhere, right? Let's say the model number of your TV is 12794. Is that quantitative or qualitative data? Why qualitative?
It's just like name.
It's just like a name. Even though it's numbers, that's not a characteristic that is on a naturally occurring numerical scale, right? In other words, it's just a group of numbers to identify this model. It's a category, okay? So even though, for the most part, numbers represent quantitative data, I would say that model numbers would be over there. That makes sense? Questions on quantitative and qualitative data? Okay. Well, when we take data, it's always quantitative or qualitative, but there are what we call various levels of measurement. And I'm going to go through 4 levels of measurement pretty quickly, but the book is pretty good. You should look at the book. You should look at some examples of that. And the least complex level of measurement that we can collect data on is called the nominal level of measurement. Nominal. This is pure qualitative data. There are people that have brown hair, blonde hair, black hair, and red hair. That's a characteristic. It's a categorical piece of data. It's descriptive. It's qualitative. But with nominal data, I can't add it. I can't divide red by brown. I can't multiply black times blonde and get any number. I can't do any arithmetic with it, right? It's good data, but I can't do anything with it arithmetically. So nominal data would be categories, labels, names, okay, ethnic, religious affiliation, okay? I can't do any arithmetic with it. Let's look at the next level, or more complicated level of data, which is called ordinal. If I say three colors, and the colors are gold, silver, and bronze, what do you think of?
Olympic medals,
What?
Olympic medals.
Olympic medals, okay? I would agree, right? Gold, silver, bronze, okay? But all of a sudden, the colors, one seems more valuable than the other, doesn't it? It's not like just blonde hair, brown hair, red hair, where there's no kind of value associated with it. But gold seems better than silver, which seems better than bronze, right? So ordinal data is qualitative, or it could be quantitative, but I can arrange it in order. I can somehow say, well, if I say A, B, C, D, F, you'd much rather have an A than an F, wouldn't you? Even though I can't multiply A times C, can't do anything arithmetic with it, but A is better than F. So ordinal data is data that is ranking data. But the interval is unknown between the ranks. What do I mean by the interval is unknown? Anybody have any idea?
How much it goes, how much is between one to the other?
Yeah, what's the difference between gold and silver and bronze? Let's say that there's some sort of a race. And let's say Garrett gets the gold medal. Brandon gets the silver medal, and they are 1 second apart. And then the third place person, okay, Nick, he comes in and he's 5 minutes behind them. He still gets the bronze medal, he's still third, but I don't necessarily know the interval. That makes sense to everybody? So I can rank, you think of like the people in sports, the top tennis players in the world, right? They have rankings, you know, they're the #1 tennis player, #2 tennis player. There's no necessarily constant interval between 1 and 2 and 2 and 3 and 3 and 4. So the interval's unknown. Oh, well, we'll correct that by saying the next level of complication or sophistication is interval level of measurement. So now the interval stays the same. And now I start to get consistent intervals, and I can rank these. Quantitative data. The data can be ordered. The differences are meaningful. In other words, like if I think of temperature, 32 degrees is warmer than 30 degrees, right? In fact, it's 2 degrees warmer. And I know that there's a consistent interval, right? The definition of 1 degree is actually some physics description of heat in BTUs, right? 10 degrees is 22 degrees below freezing. That's a consistent interval. The interval remains consistent, but it's a zero representation on the scale that does not imply none. Well, what does that mean?
0 degrees doesn't mean.
0 degrees doesn't mean there's the absence of heat. Because it can get colder than 0, right? It can get to -5, -10, right? So 0 doesn't mean none. It's just on the scale. So the dilemma with that is that let's say it's 2 degrees out. If it goes to 10 degrees, it's gotten 8 degrees warmer, right? I go from 2 to 10. Gotten 8 degrees warmer. And I know that 1 degree is a measurement of BTUs. I know how many BTUs that is. That's okay. But has it gotten 5 times as warm?
2 times 5.
I go from 2 degrees to 10 degrees. Which means I've increased the heat by 8 degrees, right? Everybody's with me there. That makes sense, right? Okay, 8 degrees, that's measured. But does that mean 10 degrees is 5 times as hot as 2 degrees? Huh?
Not in Fahrenheit or Celsius.
Not anywhere.
Well, in Kelvin it does. Because 0 degrees Kelvin is absolute zero.
But that's not an
It's
interval
not.
value.
I know.
That's an explanation. So Matthew's point is really well taken. 0 is messing us up here, right? To be 5 times as much, 0 would have to be the absence of any heat. So the answer to the question is no, it's 5 times. It's not 5 times, it's 8 degrees more. The interval is consistent. But Matthew's example is absolutely perfect. To have the ability to do that division, I have to have what's called a ratio level of measurement. And in ratio, 0 degrees is the absence of heat. So let me give you a different example. So 0 now means the absence of whatever the characteristic is. Let's say Rachel is sitting in Math 222 as a proxy for somebody and taking notes and feeding this person answers, and she's getting $100,000 this semester for doing that. Well, we can agree. Right? And Sonia is taking notes. She's doing kind of the same thing, but she's only making $50,000. That's still pretty good, right?
I want a better deal.
Huh?
I want a better deal.
You want a better deal?
Yeah.
In this case, 0 would mean the absence of any money, right? In other words, 0 has meaning, okay? You're not getting anything. So if 0 has meaning, and it does in salaries and wages, you are making twice as much as Sonia. Matthew's point about the Kelvin scale on temperature. If 0 is absolutely the absence of heat, then I can multiply and divide, okay, because I've got what's called a ratio level of measurement. Okay, where 0 has meaning. 0 has meaning. If I fill up a cup with 4 ounces of liquid, and another cup over here has 12 ounces of liquid, there is really 3 times as much in the 12 ounce as there is in the 4 ounce. Because 0 has meaning. 0 is nothing in the cup. That makes sense to everybody? Okay, good. It's 1/4. 0 has no meaning. All right, so a couple of things. I would suggest that you review the textbook in sections 1.1 and 1.2. I would think you probably want to do a little of the example problems. And next time, if you look under lesson 2, if I'm really motivated, maybe I'll write you a note to remind you, but if you look under lesson 2, it has a worksheet that's called lesson 1 and lesson 2 terminology worksheet. You should probably print that out, bring that, we'll talk about that next time. These are some of the notes I might use, but this worksheet you should print out for your own device. Okay, I'll see you on Thursday. Anybody have